Hello, welcome back to the channel. Today we're gonna discuss another challenge from LeetCode, minimum number of operations to sort a binary tree by level. So problem definition is we are given the root of a binary tree with unique values. So each value in the binary tree is unique. In one operation, we can choose any two nodes at the same level, let's say 3 and 4, and swap their values. And this is the first level, this is a level 0, this is a level 1, the next level, and the next level. So we need to return the minimum number of operations needed to make the values at each level sorted and in a strictly increasing order. The level of a node is the number of edges along the path between it and the root node. So 3 and 4 is in one level, 7, 6, 8, and 5 they are in one level, and 9 and 10 they are in one level. So what we need to do, 3 and 4 we can swap them. So we need one operation to swap them, 3 and 4. So it will be 3, 4. Initially it is 4, 3. Now it will be 3, 4. And when we in this next level, we have we first swap 7 and 5. So it will be 5, 6, 8, and 7. Then 8 and 7, when we swap, then it will be 5, 6, 7, and 8. So we total, we need only 3 swaps. And the next level, next example, 1, 3, and 2. So you can see 2 and 3, they are not sorted. So we need to swap 3 and 2. So it will be 2 and 3. We need one swap. For this 7, 6, 5, 4, we need 2 swap. 7 and 4. Then it will be 7, 6, and 5, 4, 4, 6, 5, 7. Then when we swap 6 and 5, we need one more swap. Total, we need 3 swaps. So these are the constraints. So the number of nodes in a tree is in the range from 1 to 10 to the 5. Each value in the node is from 1 to 10 power 5. And all values are unique. So we can see, so this question was asked by Amazon in the last 6 months twice. So there are a couple of hints and similar questions. So how are we gonna tackle this problem? So definitely this is going to be a level order traversal. So what we need to do, we need to collect collect the values of each node. Let's say this is a level 0, so we need to get we need to collect the values from each level into the list or the array, and in the next level, level 1, so we will have 4 and 3. In the level 2 we have 7, 6, 8, and 5, and the last level, level 3, is 9 and 10. So the problem, it has two parts. First we need to do BFS, or breadth first search. That is so we that's where we use the Q data structure. And second, after we get this list 7, 6, let's say, and 8 and 5, this is it. Then we need to get we need to sort. And first we need to do BFS, then we need to do sort. So how we gonna do BFS? BFS is simple. So we use the Q data structure. What we do, we initially put this, this is called the root node, we put into the queue, then we go level by level, we traverse this left node and right node, then we iteratively add them to the queue, and the next level we pop them and add their children to the queue if they exist. The same thing, after we go here, then we add their children to the queue. Then each level we keep level nodes list for the level nodes, and after we are done with a level, then we are going to swap the list. Let's say for this level, level nodes for this one, level nodes are 7, 6, 8, and 5, and after we collect them and we within the queue, what we do, we try to swap the places where if they are not in order. So the first challenge is BFS, level order traversal, and the second challenge will be how we are going to do to the counting of the swaps, right? So I assume you are quite familiar with level BFS, level order traversal. So after we collect these nodes by level, our task will be, we need to count the number of minimum number of swaps to sort this level nodes. So we have we are given we collected these nodes from the level. Now how many minimum swaps is required to make this array sorted, which is 5, 6, 7, and 8. So let's look. So we are given this level nodes, and after we sort, this is going to be our target. So target, after we sort them, so it will be 5, 6, 7, and 8. And originally we have 7, 6, 8, and 5. So if you look at the indices of this array elements, the first thing we are going to do, we need to construct a hash map, which is a position of the original array. So that is 7. That's the position is 0, 6, 1, 8, 2, 5, 3. So that's a dictionary. So we can see 7 is at the 0 position, position 0. But in the target, after we sort them, you can see that has to go to position 2. So they are misaligned, right? So what we need to do, we need to get the position from here and swap with this one, right? So the position 0, this is a position 0. So in the target, after we sort, position is 0. 5 should be 0, but here 5 is at 3. So we need to swap 5 and 3. So there will be 2 swaps. We need to swap this 5 and 3. 5 and this no, and 7 and 5. 7 at position 0 and 5 at position 3. So we need to swap this two elements, after we swap, what happens, 7 will be no, 7, so 5, 6 and 8 and 7. So it will be, after one swap, it will be this, and the position, we will need to update the position too. Now 7 will be at position 3. We also update the position, and we also update position 6 at position 1, 8 at position 2, and 5 position at 0. Now after we are done this, then we go to the next element. We do the same thing. If now we compare the target value at the position 1 and original value at position 1, you see, if they are equal, then we don't have to do anything. We just continue to the next one. After the first iteration, and we are first iteration, second, and after when we come to the iteration 3, we check original position here. Now it's 0, 1, 2, 3. We are in iteration 3, so we check target at 7 and original is 8. Now if they are not equal, then now we need to do swapping these two. At the same time, we also need to do the swapping of their position. So position will be 7 will be at 2, 6 will be at 1, and 8 will be at 3, and 5 will be at 0. Now finally, we can see the array, all of them are in the correct position. 5 at 0, 6 at 1, 7 at 2, and 8 at 3. So our array will be, after sorting, we'll have 5, 6, 7, 8. How many swaps we made? Initially we made here 7 and 3 and plus 1 swap, and 7 and 8, there is a plus 1 swap. So total we have plus 2 swaps from this function. Now let's look at the code and try to write up the code. So the first thing we do, if the root is none, then we return 0 because we don't have to do any counting. Then we form here queue, a double-ended queue in Python. Then we add here the root of a tree. Then we initialize swap count. Okay, swap count. We initialize swap count is equal to 0. Then we check if the queue is not empty. If queue is not empty, we check the size of the queue because we are doing the level order. So we say that, okay, level size is equal to the len of queue. Then we initialize the list to collect the level nodes. Okay, level nodes. It wants to autofill. Level nodes we initialize as empty. Then we loop this we loop through the queue. So we do for, we don't need any variable here, and range level size, let's see this, I want to do, okay, so the level size, in the level size we are going to pop the node which is Q, so I did this filling so that it doesn't take too long to type. So initially what we are doing here, we are if the root is none, then we return 0. Then we add the root of the tree to the queue. Then we initialize the counter to keep track of total number of swaps. Then we do the level order traversal, while queue, we get the size of the queue. Then we initialize the list to get the node values. And we process all nodes in the current level. So 4 in the level size, and we pop the queue from the left, and we add the value to the level nodes. Now we need to add if the left node of this node after we pop, if that exists, then we add that to the queue. And we do the same thing for the right node. If that exists, then we add to the queue. Then at the end, we get the minimum number of swaps for the level of the level nodes that we collected from each level. So swap count, we get for by that level a minimum a minimum number of swaps by each level. Then we increment or we add that to the swap count. Then we return swap count. And let's go through this method. Get minimum swap for level. Original, which is the level nodes, it's given. So we sort this by in increasing order. Then then we say, okay, minimum swap count is 0. Then we get the position of ID value and which index is that value in, and we do the go through, we iterate each element in the level. If the original position value in original position 0 and the target position target at position 0, if they are not equal, then we try to identify the what's the swap index. How we get this? We get this from a target at 0 position. Let's say in our example was 5. 0 position was 5. What's the position 5? Position 5 from this dictionary is at 3. So the swap index will be 3. So then here we swap the current value with the target value. So original position which is 7 will be swapped with 5. Then we also need to update this position dictionary. Original swap swap IDX is equal to swap IDX. Then we put this position original I to the current index. Then at the end we increment the swap count and we return the swap count. So it has, as I said, it has two parts. One is a level order traversal and collect all the nodes by level. Then after that, do the swapping in each level and count how many what's the minimum number of swaps that's required to sort this level nodes in an increasing order. Yeah, so if you have any question, you can comment and ask question. Thank you.